Alrighty, CNT120, Chapter 6. We just got done talking about access methods. Now we'll talk about association. Packet exchange between computer and access point to get internet access, so forth. First thing we have to do is associate. We have to actually have our laptop associate with the access point to be connected on the network. This is another function of the MAC sublayer, this bottom half of the data link layer. So on my laptop, if you will, I keep picking on a laptop because that's what most of us use for our wireless networks. While I boot this up, it can actually be doing active or passive scanning, and device, whether it be phone, laptop, tablet, etc. Active scanning, my client is going to take the initiative and try to probe, actually find, is there an access point out there that I could connect to? The probe frame is sent from the node to all the channels within that frequency range, hoping for the access point to respond back to me, saying, hey, I would like to associate to connect on your network. Passive scanning, the access point takes the initiative. The wireless device is listening on all channels. A beacon frame is issued periodically from the access point, and the beacon frame contains info needed for association. Okay, so there's two different ways we could be dealing with that. And we typically are looking at just this end, the user end, trying to find the wireless network I want to connect to based on its SSID, service set identifier. We'll say, hey, this is the wireless network. Well, it's actually the identifier for that access point for the wireless network, if you will. We would be looking for that to associate with that wireless network. And usually once we pick that, we then need to plug in the appropriate passphrase or encryption to be able to connect onto that network. So some different topologies that we run into, whether it be ad hoc or infrastructure, would be the different type of wireless networks we connect to. Ad hoc, for most people, you probably have not done this. This is kind of you connect your laptop to your laptop, if you will, to transfer information back and forth. That's not super common. Most of us use the access point as our middleman to move data around. But if I literally connect my two devices directly together, this would be an ad hoc network where my laptops are literally connecting directly to each other. And they would call that Independent Basic Service Set, IBSS. That's what that would be called. And this would be your ad hoc, where you're literally, there's no access point you're using, you're literally connecting device to device through wireless, if you will. What's more common for a lot of us is using some sort of infrastructure topology, where we're using an access point as the middleman or the connection point between our devices. So I would have an access point where a bunch of devices are sharing that to get access to the network to move data or get out to the internet, if you will. Now when I have my devices connected access point, that area is called a basic service set. And the basic service set identifier, BSSID, would identify all the devices that are connected to or associated with that access point. Here shows you an example of just that. If I have an access point connected to my network, all these devices here are basic service set. All basic service set identifiers identifying all of these things here, if you will. If I move up to and this is the kind of structure most of us have at home and even in small businesses, this is the kind of thing you would have. If I move into a larger facility, you can even think of like, your school you went to, or hack if you're going to classes on campus. You now have multiple access points scattered around a building, and all those access points literally, from the user standpoint, look like one giant access point that you connect to. Well, yeah, we now have a wireless controller that makes all these access points look like they're glued together into one giant access point. So if I connect to, Hack Student Wireless in Hall Tech and walk next door to the next building and connect to Hack Student Wireless, my laptop thinks it's the same network, if you will. And I don't have to literally rekey everything in and start all over. I can just connect to that wireless. Now I'm into kind of like a mesh topology where I have a wireless controller that is having all the access points. It's kind of like managing all the access points to make it look like just one giant wireless network. We now have the extended service set and the extended service set identifier. So we now might have a series of access points all connected together, or access points connected into and controlled by a wireless controller. That's most likely what's going to be going on. and I would have what's called a lightweight access point instead of a standalone. Up here I have a standalone access point where I can configure that individually. Here I have a lightweight that's controlled by the controller. I put the settings here, and all the access points get their settings from the controller. So I would not have to configure 3 of these. I configure the controller, and all of those get their configuration from the controller. That's what I would have there. The book then mentions that we might have lightweight access point protocol for controlling those, and actually having a wireless controller to manage all of those. Now, some places are still using this. Some are actually having this out in the cloud and having the cloud server manage these access points, if you will. Okay, I'm just giving you a heads up of like some of this has moved out into that scenario. And now I have the extended service set identifier. And this actually helps with, and I mentioned this earlier, here you go. When a device roams from access point here to access point here, it can literally act like it's on the same network, and it does not have to start over. It allows them to literally just move over to the next access point and stay on that same, hack student wireless, if you will. I'm doing little air quotes over here. Now, there is such a thing now called band steering. Before, if you were to connect to an access point, you would basically pick the frequency range. It's like, okay, go ahead and use that frequency range. That's it. Now, with band steering, you can actually, the access point can actually steer you to the better throughput or the better bandwidth that you might get. Before, you might use the 5 gigs for high throughput, but it didn't have the range. Sometimes you'd use the 2.4 to get a greater distance away. But with band steering, the access point can literally say, why don't you use this one here? This is your normal operation. You connect and it's like, okay, here's 2.45, you use what you want. Now with band steering, it's like, okay, why don't you use the 5 gig? You're close enough, you'll get better bandwidth. So the access point can steer you to the better frequency band to use for the better throughput for your connection, which is pretty cool. It's pretty neat. All right, let me pause 1 second. All right, sorry about the pause. When we go to design a network, the wireless network, we have to think about the devices that are being used and any kind of wireless that we're going to need to implement. So this could be affected by a couple things: the number of users, number of devices, kind of the size of the building, that sort of thing. So they start us off small, kind of like we would have in our home, smaller home office. So I typically have like one central access point. I might have a range extender, and that access point would connect to a router and probably out to the ISP. Or in some cases, it might be incorporated with that router. That's actually what they're showing here. My Soho, my small home office router, if you will, that actually has the router, the switch, and the access kind of point all built into one, and I might use some type of modem to connect out to the ISP. So as long as I centrally locate that, I would have wireless for all the devices in my house. And I might have something along this line that I'm doing it with. And again, here is the ISP connection, and then the router circuitry in there connects into the switch. That's what these ports here are. You can plug your desktop in, and then inside the access point is connecting into basically one of those switch ports kind of on the back end, and acting as your access point for the wireless users. So things like distance obstacles, how much area you need to cover, interference, are things that are going to affect where your access point gets placed. Once upon a time, I placed it in our bedroom upstairs in our house. As we added more devices onto our network, I literally reran cabling, and I have it located downstairs on the first floor in the living room where most of our wireless activity occurs. So I've moved the location of that so it's a limited distance for people when they're wirelessly connecting. Obstacles in the way, walls, ceilings, those sort of things will affect how much of an area you need to cover, and if there's other interference like neighbors and so forth or other wireless devices would all be things that you would consider, things we kind of mentioned before as well. They also mention, earlier Internet of Things. I'm reminding you again, we might have a lot of Internet of Things in our house that we're connecting as well. And I threw this out here, things like security and Ring doorbells and, thermostats and controllers for light switches and controllers for light bulbs and that sort of thing, all kinds of stuff. These might be additional considerations for placement of your device. Things like your smart speakers, things like your smart thermostats, things like smart doorbells, things like smart security cameras, and even some appliances. I know some people might be using appliances that are, whether it be a washer, dryer, letting you know when the cycle is done or that sort of thing. These would all be devices that are part of your consideration too when planning out your network. So all of those things would be considerations too. Where am I putting this and minimizing the distance to everything? Or maybe using a range extender to pick up those devices that are on the second floor or out in the garage or whatever it happens to be. As we move into a corporate setting, we might actually have to purposely do some homework in the form of a site survey. Site survey, you're actually going and trying to figure out what area do I need to cover, what obstacles are in the way, what kind of coverage can we get. And they walk us through, starting with blueprints. Look at the blueprints of the building. That'll give you distance measurements and area coverage. That'll give you kind of like a starting plan. You might need to think about, do I need to connect a neighboring building with a wireless bridge? And you might do that. You might have a neighbor annex building that you're going to connect. And you can actually do that through use of specific antennas. And you could have an antenna broadcast and receive over here to pick up and connect the two together. That can be done. That might be part of your network design. I might need to deal with multiple APs, maybe one on a floor, or maybe my floor is large enough that I need, one on each end of the floor kind of thing. How much signal strength do I need for coverage? I can increase the coverage area with my signal, but then I have a lot more devices that might connect to it. So I might reduce that signal and actually put an additional access point in to sort out or spread out the load on my access points. I then might actually get a proposed AP and kind of place it in there and see what we get and move it around. We even did this when we hooked up wireless at our church once upon a time. We got one, put it in place, and we kind of walked around with our laptops seeing what kind of range we got, what kind of signal, and that determined we needed to put, one here kind of thing to cover the initial wireless in our church. It was a real basic, test, but it gave us an idea because you can't predict what walls and ceilings and things are going to do until you get in there and try it. And then, test for corners of your building. Other products that might be in there that might be affecting, especially if you're like an open area, products in a warehouse would affect your signal. And then also consider how the wired and wireless would connect together. That's when they mention things like doing site survey and using site survey tools. There is actually applications and tools out there that you can do a site survey and figure out your signal strengths and also your dead areas in a building, especially if you have anything in place to begin with. I'm just sharing a couple that they mention in your reading. Just pulled a couple out here so you can see. So when you use that, I can start seeing what areas are covered and what areas might not be covered. So here I have nice strong coverage here. These areas up here would be dead zones. Well, maybe that's area that does not need to be covered, or maybe that's area that actually needs to be covered and somehow we're missing it. So we might need to move an access point or adjust our coverage area. That's what that can accomplish with using utility like that as I'm doing my site survey. And then as I start putting things in, I'm going to start putting all my access points together in the same extended service set so it looks like one giant wireless access point to the users. And again, I might have an access point on each floor, all connected together here. I would make all those have the same SSID for, employee wireless or visitor wireless or whatever it happens to be, so they all kind of like work together or look like they're working together. All right, we'll come back in the next and start talking about actually configuring up a network to get it running.